In this section of chapter 6, I'll discuss about stereochemistry of one chiral center. Now let me remind you what is one chiral center. That's the center like carbon with 4 different groups bonded. So I just wanted to remind you about that. I can put anything in those locations, say Cl, Br, I, and say H. Keep in mind this is tetrahedral, so actually it would look like this. C, H, and then you have a tetrahedral angle 109.5. So I would have I, and then you may have Cl and Br. So that's the actually how it would look like. In case of our hand, we call one hand as right hand, the other hand as left hand. But there is always some kind of convention that goes behind all kind of labeling. But in our case, we know that the hand which is on our right side is right hand, and hand what is on our left side is the left hand. In case of a molecule, rather than using right or left, we use R or S. So we are going to use R or S to represent two kinds of molecules. And keep in mind, these two kinds has to do with chirality center, because if I have a chiral center, then its mirror image is not going to be superimposable, and its mirror image is going to be a new molecule. So let me first go over a set of rules based on which we designate one molecule with R configuration, another molecule with S configuration. This is comparable to right hand and left hand. Now here are the rules that we need to go by. First, you need to assign priorities to the groups bonded to the chiral center. Now priorities are based on atomic number. We discussed about these priorities when we talked about EZ configurations. But to refresh your memory, let me go over these again. The highest atomic number would have the highest priority. So in this case, highest priority would have the smallest number. So in this case, highest priority is oxygen. It would have 1. Think it this way. Someone who is best in your class would be number 1 student in your class. So the highest priority goes with the smallest number, 1. And next highest would get 2, then next highest would be 3, and out of 4, the lowest priority group would get 4. So this is the first thing to do, assign priorities to the groups bonded to the chiral center. In this case, chiral center is carbon, which has the 4 different groups bonded. The second rule says that when decision cannot be reached, compare atomic number of the second atoms in each substituent. And so basically, if you cannot make a decision, look for the second one or third one until you see a difference. If there is a double bond, make sure you consider the double bond as 2 single bonds connected to the same atoms. Same is the case with triple bond. If you have triple bond, consider them as triple bonds, 3 separate bonds connecting those 2 atoms. In this particular case, carbon and oxygen has a double bond. So in other words, for priority purposes, we assume that carbon has 2 single bonds with oxygen. So with this set of rules, now we can assign priorities and then come up with designation R or S. How? I call it steering wheel analogy for RS configuration. First, you must have lowest priority group away from you. So say for example, hydrogen has the lowest priority, having the highest number, 4. That should be, you hold on to that molecule so that the lowest priority group is away from you. Hold on to the highest priority group as if you are holding on to steering wheel, and go from 1 to 2 to the third priority group. And notice whether you're taking a right turn, hypothetical, as if you're driving a car. If you're doing a right turn as you go from 1 to 2 to 3, that is the R configuration. If you're turning to the left, that's going to be a S configuration. I want to remind you this optical rotation, the plus or minuses, do not have simple correlation with R and S. In this slide, I would like to discuss how you can come up with S2-hydroxypentane or S-pentan-2-ol. So if I were you, I'd first write down the structure without thinking about R or S. So basically I'd write down pentan-2-ol or 2-hydroxypentane. And that's how I came up with the structure that you're seeing here. That's 2-hydroxy, because this is the second position. It's the second position, which is from the right, that gets 2. So that's 2-hydroxypentane. Now let's identify the groups. Then we're going to assign priorities. Let's use a different pen. This is the second group, third group, fourth group. Now we need to assign priorities because I need to understand whether it's R or S. And the question is asking for writing a structure for S. And I explained that to you, and I'm going to explain how do I come up with it. So I know that there are 4 groups attached to this carbon. This is the chiral center having 4 different groups. And let's assign priorities. Carbon is directly bonded to oxygen in case of OH, and that has the highest atomic number. So that gets the highest priority, and that will be 1. So let's assign that priority 1 on oxygen. Then there are 2 groups. One is propyl group having 3 carbons bonded. Let me show you with an asterisk. The other one is 1 propyl group, methyl group with asterisk. Both are connected to carbon, so you cannot make a decision. So look for the next bonded atom. In case of propyl, there is second bonded atom is also carbon. In case of methyl group, the second bonded atom is basically hydrogen. So there are 3 hydrogens. So obviously this group gets the higher priority. So that would get priority number 2. And then obviously methyl group would get priority 3 and hydrogen would get priority 4. So now we assign priorities to all these 4 groups. Now at the bottom I have drawn a tetrahedral structure. Now we need to assign those 4 groups around that carbon. Let's put OH group here. It doesn't matter where you put this OH group, because once you put OH and H is already there, then 2 other groups would be in specific locations, so that it's going to be left turn for you, or a configuration would be S configuration. Let's now think about it. If you look at my molecule that I'm showing you here, this molecule, the white one is hydrogen, and what you're looking at in this figure is like this. Hydrogen is upward. I can always rotate it, and that's exactly what I'm going to do now before I explain that to you. So I rotate it in such a way hydrogen is farthest away from me. You're seeing my location, and you see that hydrogen is farthest from me. And that's exactly how you're going to orient this molecule or rotate the molecule. And say my highest priority group is this, the red one, which is OH. Now the question is, where am I going to put my next priority group, which is propyl group, so that it would be a left turn. Left turn means, imagine these 3 atoms are making a steering wheel. So I'll be going from highest priority to the next priority to the next priority, and that should give me a left turn. It doesn't matter what orientation I have. Once you are experienced in doing this kind of problems, you can always imagine whether it's going to be R or S by placing your eyes away from hydrogen. So if you're looking at the picture, your eyes would be somewhere here. So looking at this carbon, and not only that, you're holding on to this. Let's change the pen color. You're holding this oxygen and going from oxygen to the next priority group. It has to be on this side. So let's put the next priority group. 1, 2, 3. So obviously that would have only this position for methyl group. So in other words, if you have this kind of attachment of OH, CCC, and C groups, this is going to be a left turn. Why? You can see here, that's how I'm holding it. And in determining it, I'm going to rotate this in such a way that hydrogen is away from me. This is my highest priority. This is my highest priority. And I'm going to the next highest would be this one. So make your own molecule and see for yourself as you go from the highest to the next highest to the next highest. If it is a left turn, that's S. And indeed, I have a left turn in this case. So building a model would be very helpful in solving a problem like this. I want to caution you that in the video clip, you probably have seen me going from highest priority group to the next highest to the next highest priority group. What is left turn for me, which would appear to you as the right turn? So I strongly suggest that you build a model and see for yourself. But the key thing to follow is how I'm doing it so that you can come up with right answer. Now I'm going to do a problem from the book, which is 6.9, and there are 3 questions, A, B, C. Let me just do one of them. This orientation is such that you may be a little bit confused in determining R or S. So again, if you build a model, it'd be very simple for you. So let me first draw the structures. This is 6.9A. Let's see. This is a tetrahedral representation. So Br has the solid line. Then CO2H also has a solid line. Because it's on the plane of the paper, in this case plane of the screen, and then hydrogen with thick line is towards you, and then you have a dotted line for CH3 that's away from you. And these are the 4 groups that we're looking at. Let's assign priorities. If you have periodic table, look at that, and Br has the highest atomic number, so its priority is going to be 1. So let me assign priority. Br has the highest priority, so get the smallest number. Next highest priority has to be determined by looking at methyl group and carboxylic group. In case you're not familiar with bonding in carboxylic group, let me show you how it looks like. C double bond O, OH. So that's the carboxylic group, that's this group. So you'd be counting as if carbon is bonded to 3 oxygen atoms. So now it's my second priority group is quite straightforward, because even though methyl and carboxylic group both have carbon directly bonded to the chiral carbon, but you can't make a decision. So you need to go to the next bonded atom with a higher atomic number. Since carboxylic acid has oxygen, so obviously this group gets priority number 2, and methyl group would get priority 3, and obviously hydrogen would get priority 4, or lowest priority. I strongly suggest that you make a model, and then, as I've shown you in last video clip, hold the molecule in such a way hydrogen is away from you. That means your eye would be on this side, and hydrogen is completely away from you in order to find out R or S. Then hold on to Br, that's the higher priority atom. So you hold on to this. Let's draw another circle here and go from 1 to 2 to 3. So that means you're going 1 to 2 to 3. Now keep in mind, your I would be here behind, or you rotate the whole molecule in your own liking, but no matter how you're going to rotate this, your I will have to be away from hydrogen. Then you go from 1 to 2 to 3. If I do that by placing myself away from hydrogen and going from 1 to 2 to 3, I'm going to get left turn. So configuration is going to be S. Make sure you try yourself. I find that students who use models, they are right almost all the time. So please have your model and build something simple with different colors, maybe 4 different colors, and assign priorities, and then you'd find yourself that you can come up with right answer. So whenever you're turning left, that would be S. If you're turning right, it's going to be R. In the same way, you can try the other problems that I have assigned, and their answers are given